Hi, here we have another question from Iranian Mathematical Olympiad round number 1, year 1997. The question is, we want to move from point A to B using the shortest path. With how many ways we can achieve this? The first round of Mathematical Olympiad in Iran consists of multiple choice questions. You get approximately 6 to 8 minutes per question. If you answer correct, you get 3 points. If you answer wrong, you get minus 1 point. So I spent 5 to 10 minutes and try to figure out the solution of this question and then come back and see the solution. The shortest possible path means that we can only move toward right or toward up. Because if we go back and come back, then this will not be the shortest path anymore. Okay, so let us start. We have a square 1 by 1. Then obviously we have two ways to go from A to B. One is here, one is here. All right. If we have a square that is 1 by 2, from A we can go to this point. From this point to B, it becomes the previous case, which is 2. And we could go here. And if we come to this point, then we have only one choice to go up. So if we have 1 by 2, the number of ways that we can go from A to B is 3. This one is 2, this one is 3. And in general case, if you have 1 by n, the number of ways that you can go from A to B will be n plus 1. Okay? It doesn't matter if it is like this or if it is horizontal. Even in that case, it will be n plus 1. All right, so now let us look at the question. We can consider these two key points. If we go from point A to this point, this is 1 by 3, so we can go from here to here by 4 ways, and from here to here by 4 ways. So if I go from A to this point and from this point to B, I can do this by 4 times 4, 16 ways. Same way, if I go from point A to this point, I can do it in 4 ways, and if I go from this point to point B, another 4 ways. So 4 times 4 is 16. This one is also 16. But we can also go from point A to this point, and then we are forced to go that way to B. Or we can go from here to here, and then we are forced to go to point B. So 1 way, 16 ways, 16 ways, and 1 way. 4 times 4 plus 4 times 4 plus 1 plus 1. The answer is 34. So the correct answer is option B. We could also solve this problem with a different approach. If we have a network that is full, so everywhere we have the grid, and let's say the length is m, the width is n, in that case, the number of ways that we can go from point A to point B using the shortest path, i.e. using the right or up moves, is the choice of n object from m plus n object. Or similarly, it's the choice of m objects from m plus n. The proof of this is rather simple. The number of steps that we have to take to move from point A to B is, so we need to go m times in the right direction and n times in the up direction. Whatever path that we select, we need to move m times toward the right and n times toward the up. So the total number of steps from point A to B is n plus m. Now, if we choose n of these total number of steps, so n from m plus n objects, and then assign them with the up direction, we actually uniquely define the path from A to B. Because when we select n moves and we assign them as up, all the right moves will be identified uniquely. Or same way we can say if we select m moves toward right, all the other up moves will be forced and identified uniquely. So therefore, the number of choices that we can go from A to B is the selection of n objects from m plus n. For example, if we have this network, this is 7, this is 5. So the number of ways that we can go from A to B is the choice of 5 objects from 12 objects. Okay, so we know this background. Now we go back to our own question. Assume that the network is complete. We have something like this. So if we want to go from A to B using the shortest path, the answer would be the choice of 4 objects from 8 objects. Because this is 4, this is also 4, 4 plus 4 is 8. So the choice of 4 out of 8. And if you do this calculation, 8 factorial divided by 4 factorial times this, it gives you 70. So the number of ways that we can go from A to B using this network is 70. But we know that whatever paths that goes from point C is invalid paths. So we have to calculate them. If we go from A to C and then from C to B, all of those paths are wrong. Now we can do the calculation. From A to C, we have the choice of 2 out of 4. From C to B, we have the choice of 2 out of 4. This is 6, this is 6, 36. So for our own problem, which we don't have this middle point, the solution would be the total, this case, minus the one that are not valid. So in this case, is 70 minus 36 is 34. You could also achieve 34 using this method. Okay, so what we have learned is that if we have a complete network with a side n and m, the number of ways that we can go from A to B using right and up moves is the choice of n objects from m plus n objects. The second point is that for some problems, if a direct approach does not lead to the solution easily, consider using an indirect method. Start by calculating all possible solutions, then subtract the invalid ones to arrive at the desired answer. Alright, so here we get to the end of the video. Hope that you learned something new. See you next time. Bye.